if you want to figure out the transformed function from the original function, always say the base function, you must follow the following orders that you say this coefficient A and this coefficient K, they represent stretches, compressions, and reflections. This D and C, they represent translations. We say these three kinds of transformations must be formed before translations, but the order of stretches, compressions, and reflections, it doesn't matter. But you need to guarantee the three kinds of transformations must be formed before translations. Okay, according to this transforming rule, let's practice one question here. If you are given this base function fx equals x squared, gx equals negative 2f 3x minus 4 minus 1. Okay, this is the base function. We have four kinds of base functions that will say x squared, x, 1 over x, square root of x, x squared. There are four kinds of base functions. Okay, first you need to compare this expression with the standard expression of the transformed function. Here, a should be negative 2k. You must be clear of here. K must be the coefficient of the whole bracket. So 3 is the coefficient of the whole bracket. So k equals 3. Here minus d minus 4. So d equals 4. Plus c equals negative 1. So c equals negative 1. Okay. Here a equals negative 2, k equals 3, d equals 4, c equals negative 1. Okay, this is the base function. Now, let's have a try to figure out the transformed functions graph from the base function. Okay, we have now the base function should be the parabola x squared. Okay, on the basis of this function, we must transform this base function according to this coefficient and this coefficient, that is say negative 2 and 3. Here, multiplied by negative 2 for this function, that is say we need to first stretch the original function, then reflect the function in the x-axis. So vertically stretched, then reflect the graph in the x-axis. So we can figure out this transformed function. It should be negative 2x squared. Okay, on the basis of this graph, we need to transform this graph according to this k equal to 3. That is say, we want to figure out the function should be negative 2f 3x. Okay, here you must be careful. Here I use f3x. f3x is not the exact expression for this function, but I use this expression to demonstrate the relationship between this one and this one. Okay, now you need to guarantee on this blue curve for every x0, we can figure out the corresponding y coordinate should be fx0, right? Here you must be careful. This fx0 should be this function, right? So if you want to get the same y coordinate, you must use this original x coordinate to divide by 3, that is say here. Okay, for this same y coordinate, the transformed x coordinate should be here. That is say, this point, its y coordinate is still fx0, but the new x coordinate should be x0 over 3. Similarly, we can figure out the other image points. That is say, for the point and this point, the image point should be here. The image point should be here, right? This is the image point for this point and this point. Then we connect the corresponding image points. We can figure out this function's graph. That you say, this one and this one, right? This is the graph of this function, okay? After this, we can figure out the next transform function. That you say, we need to transform the function according to this parameter d. It is positive 4, here minus 4. So we need to translate the blue curve to the right side by units 4. That to say, this point should be here. That to say, this distance 4 units. Okay, now we can locate the new vertex here, and this is the new graph for this function. Okay, then on the basis of this function, we need to translate the whole graph vertically, but downwards, because let's see here in our example it is -1, so we need to translate the whole graph downwards by 1 unit. So the new vertex should be here. Okay, this distance should be 1 unit. Okay, if you can locate the new vertex, it will be quite easier for you to sketch the new graph. This new graph is the final transformed graph of this function. Okay, it should be here. The red one, the red graph, represents the final transformed function -1. Okay, let's clean the graph. Here. Okay, this one, now this one. Okay, so you will figure out the final transformed function. But this expression is not the final exact expression of this function. Okay, we can change this expression to the exact expression. Gx equals -2. Here, you should regard it as this. You should regard this expression as dx. So you should plug in this expression into this expression. We can figure out 3x minus 4 squared minus 1. Okay, it is 9x minus 4 squared minus 1. Finally, we can figure out the final expression, -18x minus 4 squared minus 1. Okay, this is the final transformed functions expression. This expression. That's it.